Hey, this is Jack Handling, and this is Lab 2 Lines of Charge. First, we'll start off with the introduction, then Lab 1 review, then Lab 2 conceptual model. First, the introduction. The purpose of this lab is to continue work done in Lab 1 by creating a line charge model that will more accurately calculate Q. The physical principles used in this lab will be Coulomb's law, electric field, gravitational force, Newton's second and third laws, which are a combination of Coulomb's law and gravitational force at equilibrium, which will allow us to calculate Q, and lastly, superposition principle, which is new from Lab 1, which allows us to create our line charge model. Superposition principle lets us use several point charges to model an electric field. The assumptions we'll be making in this lab are that the U-tape can be divided into multiple equally charged segments. Each segment is considered a point charge, and the sum of all the charged segments will be the total charge. These are the assumptions we make for the charged line segment. Lastly, we also ignore air resistance. So Lab 1 review, the diagrams and initial conditions. On the right is a diagram of what we did in Lab 1, and on the left are the metrics. Length of tape was 0.202 meters, width 0.019, mass and measured distance are all recorded here. Lab 1 review, so this is our first glow script model from Lab 1, representing point charges of both tapes. The electric force on the tape B was 0.0019 newtons, and the gravitational force on tape B was minus 0.0019 newtons. Our main findings were that the charged tape had a net positive charge. The charge of the tape was 1.86 times 10 to the minus 9 coulombs, and the number of deficient electrons was 1.15 times 10 to the 9 electrons. For Lab 2, this is my glow script line. On the left part, you can see the different values specified, definition for the electric fields, line charge, and scaling. This is the next part, which is the finalization, including print functions and finalizing of the arrows and vectors. This is the first image. The image is a bit tight due to the small separation distance I had recorded from Lab 1. If you can look closely, you can see the red line on top, which represents the top part of the tape, and the blue line on the bottom, which represents the bottom part of the tape. The yellow arrow represents the gravitational force. The white arrow represents the electric Coulomb's force between the two different tapes, and the green arrows are the electric fields. The magnitude of electric force was 7.485 times 10 to the minus 3, and the magnitude of the gravitational force was 0.0197. So as you can see, this model tells us that there is a difference between what we saw with the point charge model and the line charge model. This is our second model, where we use a guess and check method in order to determine the value of charge that equalizes Coulomb's force with gravitational force. We found that the charge that worked for this was 3 times 10 to the minus 9 coulombs, and we also found that the magnitude of electric force and magnitude of the gravitational force equaled out at 0.019 newtons. So the conclusions and questions of this experiment. What if you had modeled each of your tapes as a single point charge? Like in the previous lab, compare the estimate values of the charge you get when you see your experimental data to produce a point charge model to the value you got with your line charge model. So the point charge model was 1.86 times 10 to the minus 9 coulombs, and the line charge was 3 times 10 to the minus 9 coulombs, which tells us that there was more charge predicted in the line charge model, and we can also assume that the line charge model was more accurate than the point charge model, seeing as how it represents the tape better. So, second question, why do these estimates differ? These estimates differ because there are different methods of calculating charge. Our first method in line 1 was more generalized. It used less details and didn't describe the tape as well as the second method, the line charge. So the line charge had a more accurate answer. And which value is more likely to be closer to the real value in Y? So as I was saying earlier, the lines in the charge model are more accurate because it models the real life scenario better. That's the conclusion. Thank you.